All right, so good afternoon. So I am Bill Wagner. I'm a senior content developer with Microsoft, which means I write a lot of the documentation and learning materials for C# and .NET Core. So a lot of what we're going to do with this particular discussion is I want to talk about some of the language design decisions that generate the most questions that I get. Why did they do it this way? And that's usually immediately followed with a, because it was wrong and they should have done something else instead. So I want to dive into some of those decisions that were made and why. As John pointed out a couple times in his previous talk, yeah, it's still not perfect. There's mistakes, which there always is. But now let's talk a little bit about language design in general. And one of the things we're trying to do with computer language design is we want to do two different goals. One is you have to be very, very precise in terms of how it's interpreted by the computer, whether it's a compiler, interpreter, runtime, or what have you. Because we want it to run exactly the same all the time. And we also want a very rich vocabulary for other developers so that when they read the code that we write, it's intuitive and obvious what we meant. But they're also just reading it, and they'll pick up a lot of human-like cues, which computers can't, which is one of the reasons for some of the design decisions we make. So if you think about the richness of human language, if I were to say, that's our new French teacher, or if I were to say, that's our new French teacher, I said the exact same words, the inflection was just a little different. And for most native English speakers, you interpreted those two sentences slightly different. In the one case, I said, that's the new teacher who teaches the French language. In the other one, I said, that's the new teacher who happens to be French. Just that inflection makes a difference. And that's one of the difficulties in computer language design is computers don't get that kind of inflection. We have to be very careful with our symbols. One of the big goals of C# is to make it easy to do the right thing and hopefully make it hard to write bugs. Okay? So one of the decisions they had was we're not going to fall through in a switch or case statement. Every case block has to end in a go to, a return, or a break, or a throw, would be the other way to terminate one. You cannot fall through from one to another like you could in a classic C-style switch statement. When that first came out, a lot of people said, you know, this just disallows a lot of things that we could do, where maybe for one case we do some things and then fall through to the next case and do some further processing, and it flows naturally. Okay, that was always the critique we got for that. Why would you do this? You're just making me type more, adding more characters. Well, first, one of the most common reasons for doing it is it makes it explicit. You have to say what you mean. After this block ends, if you want to fall through to the next one, you go to that next label. So you can still write the same code, but you have to be explicit about what you meant. Someone else reviewing that code can't look at it and say, I wonder if they forgot a break there, because you had to write something about exactly where you want it to go. There's a hidden benefit that comes up. For any given value, when you look at code, if you want to refactor it and move things around, at most one case block gets executed. That helps us when we added the pattern matching switch expressions, because the semantics are such that the first pattern that matches gets executed and then it will exit. So the fact that that was already baked into switch makes it a little easier to add pattern matching into the language. And there's a hidden gem that happens is that, in general, case blocks inside a switch statement can be rearranged any way you want, and the runtime behavior will always be the same. Almost always. I'll show you what we mean by that. So if I look at a little bit of a switch demo here, in terms of some of the things that we can do in the statements, if I were to write some things in terms of just a switch statement, looking at how many points you score for doing things in different points or different sports, you can see there's a few bits where everything has to happen and any case could only occur at once. If I were to comment out the second block for the third case statement, we get compiler errors on that because it will tell me that we can't have a second copy of the same constant. I could rearrange these in any order and everything still works correctly. I can put this one down further. And so on. The only way you can't necessarily do that is if I were to introduce a variable in one of these statements. I could use it later. I would get a warning or an error that it's unassigned. If I just assigned it in this, I would get rid of that error, but now if I rearrange them and move that block above the declaration, now I get an error. But don't do that anyway because it's really weird for scoping rules, which we'll get into in a little bit later. So I did that one kind of as a preview for one of the decisions that we talked about, and we'll go into more depth into how the switch statement is really changing on Friday when I talk a lot about the pattern matching features that are being added in C#7. So one of the next ones that's coming in C#7 is a feature called local functions. Local functions enable the definition of functions inside other functions. Okay, seems simple. But if we look at that feature in general, what a lot of people have said is, if I really look at what I'm trying to do with local functions, I can do the same thing with a lambda expression. I can simply define a lambda expression as a local function. Why did we add new language features in order to put local functions into the language? Well, it turns out there's three very, very good reasons for that. The first one has to do with how lambda expressions and functions are defined. So if I wanted to do a factorial expression using lambda expressions, the way I would have to do it recursively is I have to first create a lambda expression and assign it to null. Okay, that's totally useless. But I have to do that because of the rules of the language. Because now later when I want to actually assign that variable for that expression, in order to use it inside in terms of this recursive algorithm here, it has to have already been both declared and initialized, at least once. So I have to assign it to null, and then I can declare it. I've reassigned it, it's different, and now I can use this lambda expression as a local function. Okay, that's a lot of extra work just in terms of typing. If I use that same implementation as a local function, I get something noticeably simpler. The red squigglies that are going on here is because my machine has got a mixture of newer and older bits in order to run some things on the Mac. So it's bulking any of the C#7 syntax in VS Code. If I want to declare it as a local function, I have a couple different advantages. First, you notice the first statement is a return statement. I can call this function before I've declared it or defined it, because the compiler will do it single pass like it does today. Anything can be used as long as it's a member. And then I define that local function. Same basic syntax. If you look, I've defined it as a lambda expression, but I've defined that local function. It calls itself. Definitely simpler to read. I don't have some of the extra generics in there to do the func of whatever. I don't have some of that extra work. So it's simpler, cleaner syntax. So that's why we liked it. That's why local functions were added. That's one of the main single-purpose reasons. But there's a couple other interesting ones that came out. The first one is that local functions don't require allocating a delegate object. So in terms of performance and in terms of if what you're really trying to do is simply scope something and make it so you can't call that function from other places inside your code, well, local functions are better. In that first implementation, I have to allocate a delegate object. That's a memory allocation. I call it through invoking that delegate. It's a little bit more expensive than calling a function. It's not a lot, but in a hot path, those kinds of things will matter, especially the memory allocations. It turns out, one of the very nice things with local functions is that what we actually do in generating the IL for a local function is we just generate a private method. So the IL is the same as what you would do today prior to C#6 if you just made a private method. But the compiler enforces at compile time that you can't call this local function from any other place inside a class. So we can nest them inside there. You get the scoping benefits that you want. This method can only be called from inside the method where it's declared. It can only be seen from inside where it's declared. So I could declare another local function or another member with the same name somewhere else and they would not collide. But the compiler generates just a normal private internal or private function and runs through it in the same way. Okay? So that's why we added that. Lambdas effectively are different than local functions. So even though there was a way you could do it, we find that what we've added is a much cleaner syntax. Questions on that so far? Okay, those are the only ones that hit features that are somewhat new in the language. The rest of these are generally pretty evergreen. This is the one that still we get questions on. So I don't have a demo for this because we can't demo the feature that doesn't exist. C# doesn't do XML literals. Our joke about this is that VB in arrays and in storage is 1-based, so they made this mistake 1 time. C# is 0-based, and we made that mistake 0 times. So why wouldn't we do XML literals? VB developers love XML literals. They just have XML inside, put some text inside with variables, it substitutes, they generate XML. That's awesome. Well, the first thing we think about this is, okay, fine, that's easy to do, but we can use library calls to pretty much get the same effect. Why add a whole new construct to the language itself in order to support an external data format? That's a lot of extra work. That's the kind of thing that really ought to happen with libraries. Because even when this feature first came out, while we weren't necessarily certain what would replace XML over time, we were pretty sure that XML wasn't going to be the permanent data format for all time. So why tie ourselves to an external format? That's a library type of problem. If we look at it a little deeper, XML in 2017 is a little less important. JSON is certainly a more common format for a lot of web communication. Other formats are on disk and so on. So we didn't want to tie the language to a format. With John Skate here, who's convening the ECMA C# committee, we have enough work right now without tying the C# language to changes in another external format. Right now, the C# language in our standardization efforts is tied to the CLR and the CLI and the BCL types. Okay. Beyond that, the language doesn't have firm ties to some other external standard.
Unicode.
Okay, sure. Unicode, IEEE numeric formats. There's a few others that, yes, we are tied to that are pretty universal. Okay. I don't know how much Unicode is going to change.
Come tomorrow to the Abusing C# talk.
Come tomorrow to John's Abusing C# talk. That will be fun. But the big concern was that if we were to try to add XML literals into the language, the standardization efforts get harder. Now we are tied to which version of C# is tied to which version of XML, if the XML standard evolves in any way. In order to support those things, we would have to take that on. That becomes a much harder problem and one that really doesn't have a lot of value. And overall, the standards work on C# has really helped the language grow in adoption in a lot of different ways. Because C# is an ECMA standard, Xamarin could implement it. Because Xamarin and Mono could implement it, C# already had some roots in other platforms outside of Windows. And we had .NET Core. We implement that standard as well. It makes it easier to run on multiple platforms without it being taken away. Some of the rules for ECMA standards, because C# is an ECMA standard, if Microsoft decided they weren't going to continue to evolve C#, no, there's no plans of that. There's a lot of plans to continue working on things. Someone else could pick it up as a standard. So the standardization effort was much more important than adding one feature for XML. Okay, last one with no demo. Now, this is the one we have a lot of fun with and we still get things. There were arguments about this feature to the point of screaming matches when var was added to the C# language. Because it was added around the time of LINQ, and it was added as a necessary feature to support anonymous types. Right? If we don't have a name for a type, well, we have to somehow declare it, so we'll say it's var, and whatever type the compiler gives us, that's the type of the thing. So the type of the variable is determined by the right-hand side of any assignment statement. If I want to declare and assign a local variable, I can use var. Different people at different times wrote guidance that said you should only use var with anonymous types, because with anything else, you should type the full thing out. There were people who said, var is awesome. We're going to use it anytime we possibly can. Thankfully, we won. So the critique is it's hard to know what a local variable is. It's var. It could be anything. All variables should be declared with a type. That's the history of C#. Typing keystrokes is not the same as adding type information. Any var initialization is still strongly typed, so it gets its type from the right-hand side. Well-named methods, well-named functions, obviously constructors tell you what that type is. Initializations of other types tell you what that type is. var works extremely well now with tuples in C#7, which Kathleen will go into in a lot of detail tomorrow, where I can declare a tuple as just a few different fields. Doesn't have a name. It's a tuple of unnamed type. Those fields have names, and we declare those with var. Works just awesomely. So they're still strongly typed. You still get all the same benefits. You just don't have to type the keystrokes. And it reads fairly simply. But there's a few things that are really, really important in terms of working with var in terms of local functions. Primarily working with different types that do queryables. So if we turn this back, get to this, and if we look at a couple things with var. So as I said, the first two, pretty obvious. I is an integer, S is a string builder. The next three are interesting. And the reason they are interesting, they are all the same query, but I've declared the variables different. In the first case, I've declared sequence with var. In the second case, I've declared it to be a system.link.iQueryable of int. And in the third case, I've declared it to be a systems collections generic IEnumerable of int. Now, with that first one with var, remember these are the exact same queries. Someone besides John, what do you think that type is for sequence? An iQueryable event. Anybody think it might be IEnumerable event? Depends on the source sequence. Okay, in one sense you're right. Where he's looking a little bit deeper, it is an iQueryable event. And the reason that would be true that you can tell from all three of these statements together is if the query returned an IEnumerable event, the second statement would not compile. Because I would be trying to assign an object that is an IEnumerable of t to a variable declared as an iQueryable, and that would not compile. However, going the other way does, because there is an implicit conversion from iQueryable to IEnumerable. Okay? And that's actually very dangerous in code that works with iQueryable data sources. Again, somebody besides John, what happens if I take an iQueryable and I cast it to an IEnumerable, and then I continue to work with that sequence? It all gets loaded into memory. Right? If you remember, if we're working with something like Entity Framework or LINQ to Amazon or LINQ to some other data source that supports iQueryable, when I compose queries with different statements, I end up composing the query, and it's only when I enumerate that sequence that I make the call to the remote data source, parse what it should be, return the data set that I want coming back, and then enumerate the actual items that come back. Once I cast it to an IEnumerable, that round trip happens. I will get back all that data, put it in memory, And all further work on that sequence would happen in memory. Now, where that gets really dangerous and why that can show up easily if you're not using var is notice that iQueryable and IEnumerable are in two different namespaces. So if you weren't thinking carefully, you might naturally just gravitate toward IEnumerable, declare that as the type, because you know that all LINQ queries work on IEnumerable. They come back that way, and then everything happens in memory. If you compose a database query out of multiple statements using IEnumerable, every one likely makes a database trip. So instead of one trip to your remote database and back, you might make 4 or 5. And when those later ones are doing filtering with where clauses, instead of making one trip that brings back 5 records, you might make the first trip that brings back 10,000 and then start filtering and end up with 5. Much, much less efficient, much more painful. So because of that, I would, regardless of what you think about how code reads, I would make sure that anytime you're using LINQ and data sources, make absolutely certain to work with var rather than explicitly declaring what kind of variable it is. Okay? Questions on that one? So go tell all your friends, use var immediately. Works better. All right. One of the other decisions that comes through in C# that tends to drive people crazy occasionally, especially if they've ever used C or C++, is that C# defines scopes rather generously. Anytime you open up new statements, we'll try to define a new scope that defines new sets of variables. And even though that the compiler knows that a variable with the same name declared in a child scope is different than a variable of the same name in a parent scope, it doesn't let you do that, with one exception. You can, in constructors, you can have arguments that match the name of fields or properties. But otherwise, if you have a parent scope, you cannot use a name that's, in a child scope, you cannot declare a variable with a name that's in a parent scope. Even though the compiler knows, it just knows. So for instance, if we were to look at this, I now have this scope, I've declared a variable x. If in a child scope here inside an else, I tried to declare this lambda expression, and it used an argument x, which is clearly in a different scope. It's the argument to that lambda inside that else clause. The compiler tells me I can't do that because I have declared x up above, and I cannot declare a variable with the same scope. Now, what's interesting, if I declare up there, I think we end up with the same error. And now, where this plays in and sometimes gets people confused in terms of the compiler errors that you generate is this code is also clearly invalid. I'm assigning x before I've declared it. But the compiler knows what it is, and just simply says that because it's in the same scope, it says that I'm using that variable before I've declared it. Okay, even though it's in the same scope. Now, why do we care about some of these areas? Okay. First of all, the critique we often get is, naming things is hard. If I'm using the same concept or if I'm using these temporary indexes to different loops, why can't I just use the same variable? I mean, index should be indexed wherever I use it and so on. Well, first of all, you can't substitute variables of the same name because you can't accidentally refer to the wrong thing. Everything's got to have a unique name. That parent scope is there. I can't declare something else with the same name anywhere in it. It turns out this makes it easier to refactor C# for some of the tools. Because if I pull a block out and move it to somewhere else, that child scope has to have names that all matter. And I can put it somewhere else, generally speaking. If I put it somewhere else inside a parent scope that has a name, you immediately get the errors and you'll have to fix them. It turns out it's also easier to support lambdas, closures, and local functions that way because they all introduce their own scopes as well. A lambda expression has the scope with its arguments and a scope for the body of the lambda expression. Local functions have a scope that includes the arguments and the body of the local function, and another scope that includes locals declared inside the local function. So if it does pull in those extra variables from outside, you know it's coming in as a closure, and you know it's the variable in the storage from the parent scope. So the decision was made to make those scopes matter and make everything named unique, because then anytime you look at a symbol, it should be very obvious where that symbol is used and other places where the name has the same name. Okay? Yes, John?
Do you have any justification for the whole of a switch statement having one scope?
That is historical remnants from C. Because
Or is that as marketing speak for mistake?
no, yes.
It's a mistake in C that
It's a mistake in C that we wanted to carry forward because it was compatible. The reason would be this, is if we look at the switch statement, which I had up here, is a switch statement doesn't require you to have the brackets around the blocks. Okay, so switch is defined. If we look at, for instance, if I look at the code that we used on the scope demo where I'm using if and else, underneath an if is a single statement, which may be a block. And if it is a block, it must be surrounded by braces. Underneath the else is a single block or a single statement, which may be a block. If we look at the switch, well, the rules are different. Under each case is a block of statements. Since it is a block of statements and not a single statement, it doesn't introduce a scope. You know, if it wouldn't break so much code, I think we ought to enforce braces there, honestly, if you want to have more than one statement. But it is what it is. Yeah. I knew there'd be something like that from you. Okay. Now we get to overloads and base classes. So C# and a lot of modern languages have a lot of very interesting rules in terms of overload resolution. So let me update this to run the right one. So we don't need that. Or that. Now, here we have a base class, a derived class, with two different methods that have the same name. And if we notice, in the base class, the argument is an integer. In the derived class, the argument is a long. If I create a new derived object and I call the method with an integer argument, which method gets called? So John, you don't raise your hand at all because he's on the standards committee. He knows this. All right, so who thinks that the method that is in the derived class gets called? Who thinks the method in the base class gets called? Okay, there should have been more hands somewhere around there. Who just isn't sure? Okay, so isn't sure is clearly wrong because the compiler always has to make the same choice every time, right? That would otherwise break that first rule where we don't really know what a language does. Now, for those that thought the derived method would be called, the one with that takes a long, why would you think that? I'm sorry? It's an implicit conversion from int to long, okay? But why wouldn't it pick the better one that's in the base class that has an int? Okay. So who of the people who thought it would pick the base class, why would it do that? Because there's no conversion. Okay. Let's go ahead and run. And if we run it, bing, bring up a console app that we can see. Oh, fine. I left that code that doesn't compile sitting there. There we go. So what it does is it calls the derived class version. Okay, now, the reason it calls the derived class version is the language accessibility rules say that it's better to go for the closest class possible rather than pick the best match on any arguments. So effectively what the compiler is going to do is it's going to look in type D, which is the static type for that object, and it will immediately say, I've got a method that works. You are correct. Part of why it can do that is because it's an implicit conversion. And then say, let's just do this. It doesn't even look in the base class for a different method. So let's do a couple weird things to make this just... So if I were to change this, leave that as a D, but if I declare this as a type B, now what method gets called? The one in the base class. So if we run that, and finish the build, there we go, and now it calls the version in the base class because the static type of that variable is a base class object. Okay? Well, we can have a little bit more fun. This is where this part is hard, and maybe there were some mistakes here. I don't know. Change this back to var. Let's make this. We'll leave that there, and we'll add an overload here. That takes an int. Okay, so now you see I get a warning here, and I should introduce the new member because I'm overriding a non-virtual method in the base class. So, okay, so now we should go ahead and call the derived class version again because now I've created one in the derived class that has the right version, and now it's going to call the version that takes an int parameter because that argument is better. Okay, cool. We think we know these rules. Yeah, let's change this now to make this virtual. And then this becomes an override. Not new, needed to change the other keyword.
And reorder void and virtual.
Sorry?
In B.
In B, thank you. And now when we run it, it calls the overridden version in the derived class because we have a version in there. Yeah? Or no, excuse me, it calls the version that takes the long. This is the one that could be a bit of a mistake still. And the reason is the rules say that the method that takes a long is newly declared in the derived class. The override is actually declared in the base class, so it's still declared in the base class whether you override it or not. So it resolves the same way. So why are these rules in here? First of all, don't do this. Okay, let's just start with that. But the reason these rules are here is the idea behind this for the C# language designers is to try to do what they could to make it a component-oriented language. Yes?
I have a question. What if it was from an interface and not from a base class?
What if it was from an interface and not from a base?
You're not declaring it as an override in that sense. You're declaring it as a new member. So would that affect the override?
So if I change the class B to an interface, If it was an implicit implementation, it would call the version in the derived class. If it was an explicit interface implementation, it would only do it if it was cast to the interface. Okay, so to go through the rules here, what the language team was trying to do, and the reason for a lot of these rules, is to try to make a component-oriented language. So in addition to being object-oriented language constructs, the goal is that base assemblies should be able to be updated without breaking derived classes that are in your assemblies that are part of your application. So BCL and others can update underneath a running application, and you should not have things break. So that gets to some of these rules. If a later version of the BCL introduces a new method that happens to be a better argument match for one you have, it should still call the one you knew about. Right? If you didn't recompile things, it should still call the version you thought was there. So new methods can be added to a base class without breaking overload resolution. Derived classes win, always. The declaration one is, well, if you think about it, a virtual method is declared in the base class. So even if it is overridden in a number of derived classes, the declaration space for it is that base class. So that was the reason why they went there, is that those should, in fact, always come in that one spot. Now, this being a fairly small demo and a small set of code so we can see it on screen and analyze it, this feels wrong. In really large applications where you may be 2, 3, or 4 levels deep, or if you use ASP.NET MVC where you may be 5, 6, or 8 levels deep in an inheritance hierarchy, it really helps to have the methods that you actually see be the ones that get resolved rather than ones that you don't see. So that's a lot of the reason for these rules. Okay, and now you can amaze your friends and write code that John will have to answer questions on Stack Overflow. All right. And again, the main thing we're trying to do is looking at the derived class should enable you to determine the best method immediately. If you don't find any match there, then you have to dig deeper. New classes can be updated and new overloads changed without changing anything in terms of what it resolves to. So if you get a new version of the BCL, any methods that were in your class should still be the ones that get called. Also turns out that static analysis for overload resolution is a little simpler. If you were following along in the Roslyn repo, we had a feature in C#6 that was added that was called better betterness, where all these rules are in terms of picking the better method. That code got really old and ugly, and now it's better. So we have better betterness. We found a bug, and in C#7, you'll see a feature for even better betterness, by the way. Okay, last big interesting one that we get a lot of questions on with a nice tip in it is partial classes. So you're probably familiar with tools that generate classes for you. And when they do that, they almost always generate that class with the partial class keyword so that you can add your own implementation of some methods and add methods to that existing class. Okay. Now the rules for this suddenly become a little complicated because what we have to do now is, because C# is single inheritance, there can only be one base class described for that partial class. So either every file that declares part of that partial class must declare the exact same base class, or it can omit any base class. I would recommend omitting the base class because then if the tool changes and uses a new base class, it doesn't break your code. The interfaces are very interesting and different in that because interfaces, we can have multiple interfaces. Any text file that adds to a partial class can declare new interfaces that that class must support. And this becomes a really interesting feature. But the critique we get is, this can be really confusing. I look at the declaration of a class, I can't tell for sure what interfaces it implements. I'm not even really sure what base class it has because I may not declare it. And it's just hard. You should make them all the same. Well, no. First of all, we're not going to do that. So what we should say is, well, maybe we want everything to be in the same. If If you want to, go right ahead. You can redeclare interfaces to your heart's content. The first thing I would recommend is don't declare the base class on your implementation for a partial class because tools can change. The hidden one that I really like is because your additions to a partial class can implement new interfaces. It provides a much, much easier way to build test harnesses around tool-generated classes. So let me show you what I mean. So the last demo that we put together is if I look at partial classes, one of the most common places that you'll run into it is using a tool like Entity Framework. So I took this code right out of an Entity Framework core demo, so it's a blogging context. So it's an Entity Framework class designed to work with a blog engine. So if we look at the context, it's going to have a DB set for blogs. Maybe you have more than one blog on the site, and a DB set for posts, individual blog posts. Has the override that configures it. I'm running on .NET Core, so this would be using SQLite if we ran a full demo on this. And you can see that we have the model classes for a blog, which would include a list of posts, and for a post, which would have an ID, a title, content, and so on and so forth. Now, this is incredibly hard to mock. If I want to write unit tests around all the code that's using this, it's truly painful. Because the base class, this DB context, has a lot of methods. It has a lot of things that are tied to a database implementation. A lot of them aren't virtual. It's hard to override them. It wasn't designed to be able to be mocked out. In fact, even the DB set really isn't designed to be mocked out. So what a lot of companies end up doing is they'll take something like this and they'll say, I'm going to write a wrapper around the blogging context, which implements some interface I want, and then I can defer everything and call the methods inside the context, and I can mock that and do all that. That's a lot of work, for one. It's also a rather leaky abstraction, right? I can still probably get around it and do something that I want, and then suddenly I'm writing untestable code. So let's think of an easier way to do it. Well, what I'm going to do is I'm going to make my own interface that I'm just going to attach to that partial class. So I define a my application context, and I have a couple different examples here. The one is with the DB set, I'm returning it as an iQueryable of blog, which is one of the interfaces that's implemented by DB set. Because DB set itself is also very, very hard to mock, and it's not partial, so we can't do the same trick. So I'm going to declare that to be an iQueryable. And the other one I'm going to do is I'm just going to, as an example, add the save changes method. Save changes is one of the methods that's in DB context, so I can add that to my interface. Now, if you note, I add my partial class here for my blogging context. I don't have to even have an implementation for save changes because that's already in the tool-generated code. In production, I'll just call the version that's in the blogging context. And if I wanted to, for a, but I do have to do a little bit of work on the posts and the blogs because DB set is different than iQueryable, so I have to massage the return type there. So I've written a method in the interface. Then what I want to do is if I take DB, I can write my own mocking class or use some mocking framework, and I'm going to declare that I'm just going to implement that interface. And I can expand this to be anything I use in DB context, and those are the things that I would have to put together in terms of mocking out this class. So any tool that generates a partial class, I can define the interface that I want, as long as the return values of anything in that interface are something I can also mock. It becomes very, very easy to work around and just to add that capability for classes that may not have been designed with testing in mind. And it ends up being a lot simpler than wrapping it and writing a whole lot of one-line methods and making sure that you never touch the actual tool-generated class anywhere in your code. Questions? Okay. And with that, we're getting reasonably close to the end. These are some of the most common things that I've seen in terms of questions on C# where people really wonder, why did they design it that way? And I'm curious about what any of yours are. What things do you think are just like, why did they do that? Yes. I'm sorry.
Why do both dictionary and read-only dictionary implement iDictionary?
Why do both read-only dictionary and dictionary implement iDictionary? I don't know the answer to that one. I think that's more in the framework itself. Other than for historical reasons, because the non-read-only ones came first, is really the biggest one there. Yeah. See a question over here? No? Yeah. Okay. Yes.
Why on earth am I allowed to set an enum to an integer value that isn't in the set of enums that are in that enum set?
Why am I allowed to set an enum value to a number that isn't in the enum set that was defined for that? I think a lot of the original design for that was due in part for performance, because its underlying data storage is an int, or a byte or whatever you declare it to be. So its underlying storage is that. And in order to restrict it to those values, the compiler would have to inject code to check each assignment in order to make that happen. Okay, so that would get rather expensive over time. That's probably the biggest single reason. I think serialization was a bit of a consideration as well, but I think the biggest one was the performance in terms of making sure that enums are actually efficient to use. Mm-hmm.
Also the flag enums, you've got 1, 2, 4, 6, 1, 2, 4, 8, 16, and you OR things together, you'll get numbers that aren't 1, 2, 4, 8.
Right, but that's still a closed set, so you could
If I
yeah.
if I do bitwise OR on 1 and 2, I get 3, right?
Right.
Which isn't one of the things that my...
But if the compiler knows it's a flag enum, it knows that it still has a closed set of the values that it could take from that. Yeah.
Which has just reminded me, why are flags and enums the same thing when they're clearly not?
Do you want to answer that one then?
No,
I
and why do you have to give explicit values to flag enums if you just declare flag enums of red, green, blue, and I can be any of those colors or any combination, it'll do the wrong thing because it'll give you values of 0, 1, 2. That's useless. Should give you 1, 2, 4, clearly.
I don't know the answer to that one either. That's a
Flag is a part of the spec, I think.
no. I think it does it.
Appendix D.
Yeah, it's. I don't think it's in there.
Cares about flag attributes at all.
No, well, no, I don't think it does. You're right. Okay.
Possibly it should. Bitwise masking of non-flag enums. Maybe it should be removed.
I bet you can do that.
You can, because it doesn't care about that.
Yeah. I trust you. Okay. Okay. Others? Yes. Why don't we have extension properties? Why don't we have extension properties? It has come up as an idea a few times. What's that? I know it has. From a release standpoint, it's come up as an idea a few times. One of the harder things to solve there is where to store that and to keep track of that. That would be the primary reason, is to try to figure out exactly where that storage goes for an extension property. And it has come up, and it continues to come up. It hasn't bubbled up to the top of the list where it has been implemented. And the same thing is true with extension indexers, which is kind of cool. The syntax proposed for extension indexers lets you type this more times in a row than you would ever want to. Because I could say, let's see. Let me just make this. there, which would be how you would write an extension indexer. So you get to write this a few times in a row. It has been looked at, and it still is on the table. I believe there is a Roslyn issue related to extension properties. If you wanted to comment on it and add your voice there, C#7 is coming to release, so discussions are starting on what will happen in C#8, and I'm sure that feature will come up again. Other questions? Yes.
Why did they include the appalling \x escape syntax in string literals?
Why did they include the appalling \x in string literals? Historical.
But it's a clean break. Get rid of it.
There's there's an interesting thing there, and I think, and this is more my opinion than knowing everything about all the design meetings. If you look at the languages that are getting a lot of adoption, a lot of them, the curly brace languages are generally get more adoption, whether that be C, C++, C#, Java, JavaScript, and so on. Because for a large number of programmers at any of the times when those languages were introduced, could read them and, despite warts, be productive in them relatively quickly. So I think with all of those languages beyond C, there was a fair amount of design that went into saying, I want this to be familiar to the people we're trying to attract to this language.
We got rid of a bunch of the other warts. Do you want to explain the problem with the variable length?
What's that?
Can I?
Go right ahead. I'm not sure where you're going to on this one.
So
This is the Mac, though, too.
that's all right. Have you got CodeBrush installed?
No.
Right. So if I have string x equals \x 09 good. Okay. Ignore the string y equals \x 09 bad. Those look like they're both tab followed by good and tab followed by bad. Yeah?
No, they're not.
No, they're not, because B and A happen to be hex characters and G and O aren't. So this second one is 2 characters long. It's equivalent to U plus 09BA followed by a D, whereas this is equivalent to U plus 0009 good.
Right.
And I don't think that's intuitive.
No, it's not. But it hasn't been intuitive in any of the other languages that did it either.
Was it variable width in C, or was it always 1 character?
What's that?
Was it variable width in C, or was it always just 2 hex digits?
In C, it was probably always 2 hex digits.
Right.
Yeah.
So the badness wasn't there.
You would be the one to find those. Okay. Any other questions? Did you write an issue about that, though? Yes.
If I'm not mistaken, the new tuples are mutable value types?
Yes.
I didn't love it to start with either, but I have come round. Think of it as a bag of variables.
Yeah. So there are 2 reasons for this. The question was sort of posed as a statement. The new tuples are mutable value types? Yes, they are. So the new tuples are first of all, they're value types because we avoid allocations, okay? Which is also why there are a lot more generic classes for those. If you looked at the system.tuple, it went up to 9, and then the 10th one was another tuple to add more. It was really bizarre. And the new value tuple, I believe it goes up to 22, right? I think. I haven't stressed it yet. I think it's either 15 or 20, but there's a lot. So that's why they are value types, because then they can be worked as value types. We don't have allocations. Okay. Why are they mutable? Because we've always said value types shouldn't be mutable or should be immutable. The reason they're mutable is, as John says, just think of it as a bag of variables. The problem tuples are really trying to solve is I want to return more than one thing from a method. right? Because we already can pass more than one argument to a method. I don't need tuples there. I want to return more than one thing. And it doesn't have a name. It doesn't have structure. It just has more than one thing, okay? By making them mutable value types, a lot of syntax gets easier and more natural in that I can declare the individual variables. I can work with those individual variables, which, well, they're not mutable. They're copied in place with integers and such. And then I can return the tuple. I can deconstruct it. The copying is generally simpler. We don't have to copy references. And as long as you don't use a tuple as a key for a hash set or a dictionary or a hash-based container, you're going to be fine. The chances that you would really want to do that because they're an unnamed type is really pretty low, is what we're thinking. And I would say the prescriptive guidance for tuples is that I wouldn't make them part of the public interface for classes. It's certainly legal. I'm not sure it's a good idea. Okay. And almost certain Kathleen will cover this tomorrow. The names that you get with value tuples only get added to metadata if they're public. Otherwise, it's just compiler magic that takes your semantic name and maps it to item 1 and item 2. Okay? So they become very, very lightweight. And as John says, if you really just think of it as just I'm returning more than one thing, it's super simple. Does that mean they break dynamic typing? No, they shouldn't, because you do have the metadata on them for when they're public. Yeah.
But if you have an internal method,
Yeah.
returning a tuple,
Mm-hmm.
and then you're assigned to a local variable where you keep
Right.
those,
Yep.
and then you do dynamic d equals that local variable.
It would still be. It would.
d dot x.
Yeah. It would still work. Well, once it's dynamic, you're not going to get the IntelliSense on the type anyway.
It won't get any
Right.
sense, but will it work?
Will it work? I'd have to try that one.
When to accept it.
Yeah. I'd have to try that. I haven't looked at the spec on that part yet. Don't do that. And I might not, because the storage is still item 1, item 2, and so on. Yeah. Okay. Time for probably one more question. Okay, John. Oh.
Why is the default literal type for 0.5 double rather than decimal, which probably you want more often or will cause less confusion?
Why is... do you mean 0.5 as a specific number or in general? Any literal?
You're typing the decimal number.
Right.
The type should be decimal without a suffix.
The general case was meant to be that it was more going to be for floating point math and use double precision rather than specific ranges in currency and such for decimals. So given the community at the time, the fact that scientific computing was probably more likely than the decimal and currency, and that the decimal and currency was going to be the more special case, they went with double. Yeah. Yes?
What would be one thing you would change if you could?
Well, it is one thing I would change if I could.
John's got many, obviously.
Yes. What? I actually disagree with that, but that's just me. The one thing I would change, John's would be sealed by default. The one thing I would change is, in hindsight, I don't think I would have added dynamic. It's a lot of heavyweight stuff, and as it turns out, it's been used a lot less than I probably thought it would have at the time. But that's only with hindsight, honestly. Yeah, that's probably that is definitely the one that I'm like. Mm-hmm. And with that, thank you very much. I'll take any more questions up here as we get ready for this person.